Number systems. When we type some letters or words, the computer translates them in numbers as computers can understand only numbers. Again, you have to take note of this. The computer cannot understand anything other than numbers. Dili na siya kasabot o hatagan mo na siya letters, words, bisag unsa pa na siya kanindot o unsa pa na siya ka-specific, the computer cannot understand that one. Okay, once again, the computer can only understand numbers. But what kind of numbers does the computer can understand? Because the computer cannot understand all the numbers also. A computer can understand the positional number system where there are only a few symbols called digits. And these symbols represent different values depending on the position they occupy in the number. The value of each digit in a number can be determined using number 1, the digit, number 2, the position of the digit in the number, and then we have the third one, the base of the number system. I guess you are already familiar about the base of the number system. Okay, for example, we are using decimal number system 1 wherein the base of that specific number system that we're using is 10. Okay. Number systems are systems in mathematics that are used to express numbers in various forms and are understood by computers. A number is a mathematical value used for counting and measuring objects and for performing arithmetic calculations. We are very young when we first know about what is a number and what are the uses of numbers. How can we apply number in our daily lives? What are the applications of numbers? And how does it contribute to our knowledge towards pursuing our goals in the future? Numbers have various categories like natural numbers, whole numbers, rational and irrational numbers, and so on. Diba? If you're going to look behind about what you have heard or what you have studied when you were in elementary, diba? Na aning mga lessons sa inyong math teachers. Rational, irrational, whole number, natural numbers. We even studied about fractions, diba? Similarly, there are various types of number systems that have different properties, like the binary number system. We also have octal number system, the decimal number system, that's the one that we are using today, and the hexadecimal number system. Do not worry about them, we're going to talk about them one by one today. In this article, we will explore different types of number systems that we use, such as the binary number system, octal number system, the decimal number system, and the hexadecimal number system. We will learn the conversions between these number systems and solve examples for a better understanding of the concept. The number system that we use in our day-to-day life is the decimal number system, right? Decimal number system has base 10 as it uses 10 digits from 0 to 9, di ba? Unsaon na to pag-ihap, di ba? Mag-count man ta. And ang atong gibasihan is base of 10. Kaya nga naman, ingon lagi ka man base of 10, 0 to 9 naman lagi na. Yes, it's because you have already counted 0. So, 0, mag-count ka 0 up to 9, kung ipon na nimo tanan, 10 na sila kabuo. In decimal number system, the successive positions to the left of the decimal point represents units, tens, hundreds, thousands, and so on. Kani kinumdumon ni. Diba? Aha man na siya ang iyang position, makibaw ka tens place, hundreds place, thousands place, and so on. Diba? I think it's the best time to recall your previous learnings, previous mathematics learnings. Diba? Katong mga ipagtudlo sa inyong math teacher sa una sa elementary to. Gamit na ninyo karon. Each position represents a specific power of the base 10. For example, the decimal number 1, 2, 3, 4 consists of 4 digit, diba? 1, 2, 3, 4. 4 digit in the unit position. 4 siya sa unit position, 3 in the tens position, 2 in the hundreds position, and 1 in the thousands position. Mo na siya nga, the value can be written as, mo na siya nga, kung unsay iyahang position, kung naka-unit position na siya, i-multiply nimo siya 1, and niya, madugangan na siya 0 sa iyahang right side if magkataas na. For example, tens, mo na siyang 8 times 10. If hundreds times 100, if 8,000 position is 1,000. That's why, kung tinambano na to, giunsa na to ning 1,234, giunsa na to na pag-come up ana, ikuha na to ilahang place, ilang position. So si 4 ka unit position man siya, mo na nga gi-multiply na to of 1, which is kaninga part. And then si 3 kay na siya sa tens position, mo siya ato siya gi-multiply of 10. Si 2 kay na siya sa hundreds position, gi-multiply na to siya 100. Si 1 naasa siya sa thousands position, gi-multiply to 1,000. So ang product ana nila tanan, i-add na sila and it will come up to 1,234. But then dili naman ta moagi og mga ingon ana kay na-used to na mabuta paggamit ani nga system. Your challenge today is to interact with the binary, octal, and hexadecimal as the same thing as you interact with our current number system, which is the decimal number system. Given below is a chart of the main 4 types of number system that we use to represent numbers. Kani, kita ninyo? Natay decimal, natay binary, octal, and hexadecimal. Mao gini silang upat magkuyog. But then, we are only using decimal numbers. Decimal numbers base 10, binary numbers base 2, octal numbers base 8, and hexadecimal numbers base 16. Wherein decimal numbers, the counting process of decimal numbers, it will start from 0 and will end by 9. For binary, only 2 digits are involved, only 0 and 1. However, octal numbers, we have 0 to 7. 8 na sila kabuok. Kabantay mo nga may kag base 10, pasabot 10 ra na kabuok ng digit sa ana nga number system. That's why sa atong number system, we have 0 to 9, which is if you are going to count, they are 10 in total. Base 2, pasabot duha ra kabuok, 0 ra og 1. Base 8, 8 ra kabuok, 0 up to 7. And then base 16, which is 0 to 9 and 8 to F. Ganun medyo dako ni nga hisgutanan pero kaya ra niya ito siyang i-discuss later. Let's begin with binary number system. Mag-ihap ka kung binary ang imuhang gamit, 0 o 1 ra jud na kanunay. Ma'am, is that possible? Yes. Okay, it's also possible in our decimal number system to count, diba? How can it be impossible kung binary? Now, where in fact, binary is the number system being used by computers to work. Mingon ta nga, computer itong gamiton kay paspas, bright ang computer ingon ana. But then, if you only know, computer is using binary number system, which is the machine language. Let's talk about binary. The binary number system uses only 2 digits. Again, 2 digits from the word itself, by. So, nang by, duha. By. Duha pasabot ana. Okay? Binomial, may na, binary. So, 2 uses 2 digits. And the digit is 0 and 1. Kabantay mo sa inyong mga switch. Switch sa balay ninyo. Iwanan na siya 0 o 1. 0 means off and 1 means on. The numbers in this system have a base of 2. Digits 0 and 1 are called bits, and 8 bits together make a byte. So, pangutanon mo, how many bits are there in 1 byte? There are 8. Okay? The data in computers is stored in terms of bits and bytes. Kabantay mo nga, pila man maoy kanang file size, gidakon sa file ani. Kanang Word document gitahay, that is 1. Igutan na to, maingon ka nga. Kuan nga, na diri kay 10 KB. That means 10 kilobytes. So, pilam na, that is 10,000 bytes. Approximately, more or less, 10,000 bytes. Okay, kay, if I'm not mistaken, 1 kilobyte, that is equivalent to 1,028 bytes. But I have to check on that as well. Okay? I then forgot about the conversions. And then, by the way, mag-convert ta o maabot na ta sa atong laboratory nga subject. Since lecture pa man ta karon, lecture ta na atong ihatag karon. So, stay put sa mo relax, mag-solve that rata ani in nag-laboratory na nga subject. Now, let's continue. The binary number system does not deal with other numbers such as 2, 3, 4, 5. Si computer, di na siya kailag 2, di na kailag 3, 4, 5. For example, we have 1, 0, 0, 0, 1, 2, 1, 1, 1, 0, 1, 2 are some examples of numbers in the binary number system. But, okay, my base is 2. I use only 0 and 1. Kani day siya class, no, this is base, supposed to be base. Ano naman siya ha? Pag base din ako. This is supposed to be, kanang nasa ubos bitawan ng gamay ra siya. I forgot the term. Subscript, yes, that is subscript. Subscript of 2. So 1, 0, 0, 0, 1, subscript of 2. 1, 1, 1, 1, 0, 1, subscript of 2. Superscript man ang babaw ng exponent. So in the binary number system, may name siya, my base is 2. That's why I use only 0 and 1. Next, octal number system. Si octal po, from the word itself, octal, di ba ka, ano polygon nga octagon, that is a shape, that is a polygon having 8 sides, di ba? In your geometry ninyo, niagi mo tanan ana. The octal number system uses 8 digits, 0, 1, 2, 3, 4, 5, 6, and 7 with the base of 8. Again, og ipon na nimo tanan 1, 2, 3, 4, 5, 6, 7, 8. So, na siya nga octal. But sa octal number system, dito kita 8 ana. Mag-play ra na siya 0 between 0 to 7. The advantage of the system is that it has lesser digits when compared to several other systems. Hence, there would be fewer computational errors. Digits like 8 and 9 are not included in the octal number system. Just as the binary, the octal number system is used in mini computers but with digits from 0 to 7. For example, 358, this is 35 base of 8. I'm so sorry, this is typo with class. If you are intently listening to this lecture of mine today, please correct it yourself. I really am so sorry yun. This 8, kaning 8 sa last ani, this is subscript. Again, kanang ana siya sa ubos ra ingon ana. Dili na siya latapad ni 35, 23 nga na. Kay that states lang nga that number is in octal form. 35 subscript of 8, 23 subscript of 8. Okay, that means na 35 base 8, 23 base 8, 141 base 8. These are some examples of numbers in the octal number systems. Okay, my base is 8 and I use only 0 up to 7. And then we have here decimal number system. It's very common. It's because this is the number system that we are using today. Currently, presently, we are using this number system. The way we count, diba? 0 up to 10. How many fingers do you have? 10 fingers. The decimal number system uses 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 with the base number as 10. The decimal number system is the system that we generally use to represent numbers in real life. If any number is represented without a base, it means that its base is 10. For example, okay, let me correct this one sa akin. No, it can bring you total confusion if I'm not gonna correct this right now. Alright, so nga ni siya, base. Pasabot na siya sa ubos. If any number is represented without a base, kintahay, number na siya, wala yung mo siya gibutang base 2, base 8, base 16. That means, automatically, it means that its base is 10 by default. For example, 723 base 10, 32 base 10. Pwede na siya i-write as 723 or 32 or 4257. Okay na siya. That's totally fine without the base 10. Okay, again, if wala siya base, that means default na siya nga 10. These are examples of numbers in the decimal number system. Okay, my base is 10. I use only 0 to 9. Next, hexadecimal number system. Hexagon, diba? That is a polygon having how many sides? The hexadecimal number system uses 16 digits or alphabets. Kaya nga naman, the digits 0 up until 9, 10 lang na sila nakabuok. That's why nikuha siya sa alphabet A, B, C, D, and E, and F in order to complete the 16 digits or alphabets with the base number as 16. So here, A to F of the hexadecimal system means the numbers 10 to 15 of the decimal number system respectively. Kaya nga naman class, A, the equivalent of A is 10, the equivalent of B is 11, C is 12, D is 13, E is 14, and F is 15. This system is used in computers to reduce the large size strings of the binary system. For example, 7B3 base 16, 6F1 base 16, 6F base 16, F1 and 4B2A base 16. These are some examples of numbers in the hexadecimal number system. My base is 16, I use only 0 to 9 and A to F. Okay. Don't worry too much about the conversion. Timabot rataan na pohon sa laboratory. Now, let's go ahead and talk about the importance of number systems. It is safe and wise to agree that number system holds its importance for everything which includes proportion and percentage. Number system plays a crucial role both in our everyday lives and the technological world. With its myriad qualities, it simplifies our lives a lot, which has been discussed as follows. Number 1, so kung ka-importante nga natay number system, just imagine the world when we don't know how to count. Lisod kaayo, if wala tayo number system, ambot na lang yun. Hasta orasan, di ta kahibaw. Okay, the first importance here, as general niha, life in general ni siya. It enables to keep count of all the things around people. Mag-ihap, kani. Lisod kaayo, ta kabong ihap. Like how many apples are in the basket, or the number of milk cartons to be purchased, etc. Next, it enables the unique and accurate representation of different types of numbers. And then, making a phone call is possible only because we have a proper and efficient number system. Elevators used in public places also depend upon number systems for their functioning. Computation of any kind of interest on amounts deposited in banks. Creation of passwords on computer security purposes. Encrypting important data by converting figures into another number system to avoid hacking and misuse of data. It enables easy conversion of numbers for technical purposes. And the entirety of computer architecture depends upon number systems, octal, hexadecimal. Every fiber of data gets stored in the computer as a number. The number system, okay, so mo to siya in general. But then we have also here specific importance of number systems in the field of computing or in the field of computer technology. Kaya nga naman, we are talking about computer here. So ato ang i-try o hatag og justice. I-justify na to ba nga? So makaingon mo nga, ano magtuon na ta ng mga binary nga. Hindi man na magamit siguro. Okay. So, unsa may contribution adto sa ato ang computers? Unsa may kalabutan ni binary, octal, hexadecimal ni computer ug sa tanan nga ato ang nagamit karon? Because karon no, magamit ang mobile data, internet, wifi, ingana, that is part of computing and that is part of computer technology as well. Okay? So, the number system plays an important role in the functioning of a computer. The base conversion, kanto, base 2, base 8, base 10, base 16, they help both the computer and the user to understand the data and information. Computers represent all kinds of information and data from audio, images, videos, etc. in binary numbers. Diba? How amazing it is. Tanan inyong nakita, tanan inyong napislit diha, even when you are playing Dota or ML and whatever, the computer and the technology behind that one is using binary numbers. That means they are only using 1 and 0 and nothing more. Our general mode of communication with each other is made of letters or words. We send our message or information through the keyboard by typing letters or words. But computers don't have brains like us. Again, computers do not have brains like us. Giprogram man na sila to understand this and that. So how do they understand us? Di unsa man jud ni computer pagkasabot sa ato ang language. Kay lahi man tag language. We have human language. We are using human language in order to communicate with people, with humans as well. But how can we communicate to computers? Thanks to the compiler that makes computers understand our language. Compilers, kaya tinatawag na itong compilers, they change the human language to numbers. They change the human language to numbers na can be interpreted rather, and can be understood by the computer. Thus, computers understand only numbers. In computer system architecture, there is a unique technique of representing numbers called number system. That's what we have talked earlier, di ba? The number system supported by computer architecture is shown in the previous slides. It's what I have talked a while ago. And we need to study them and understand the conversion technique between them in your laboratory subject. So, relax ta. Dili pa ta mag-convert karon. Or basi ganahan mo mag-convert ta. You can do advanced study about this one. Next. Okay. The number system is used in a computer system for better communication and representation. The computers can only understand numbers. Therefore, it converts every letter and word into numbers for better understanding and processing. The digital computer converts or translates every data and information like audio, video, graphics, text into binary form, for example, zeros and ones, which is easily read and understood by computers for better functionality and proper outputs. The output generated by computer is in human readable form. Kaya nag-exchange yung computer ang nahatagan na po niya of 0 and 1. That's why i-translate na po na siya through compiler para mahimo siya ni human readable form and vice versa. Humans have used the numbers for ages. Gradually, humans evolved themselves, and with the help of their exceptional intelligence, they discovered numbers to make their life more easy and convenient. Again, mayroon mga kapuya math, uy, may kamao anang math pang uy kay lisod man na. Yeah, di ba may kamao anak mo kanang convert uroy. But then, imagine the world without mathematics. Imagine the world without numbers of counting, number system of counting. It's very, very hard. Kalisod galit ta karon no nga we are too knowledgeable and we are being sent to school in order to learn this and that. Pero maglisod pagalita, how much more kalat tayo number system. Before, numbers were used for counting, numbering, and calculations, but they were used for multiple purposes as the days passed. Okay, robotics. Mga robot nga nakitaan karon, AI, artificial intelligence. Everything that you can do online, those are applications of computer technology with regards to number systems, especially machine language, binary. We already know that computer systems cannot recognize or understand the data or instructions given to them, diba? They firstly convert that data and instructions into binary form, which is easily understood by computers. Dili gali na mahimong binary, di gyud kasabot sa computer ang sa taon. All the letters, words, symbols, special symbols are converted into binary form, and this is done with the standard code commonly known as ASCII. ASCII, that is read as ASCII. That stands for American Standard Code for Information and Interchange. By the way, kana bitong ENIAC, di ba? The shortcut key for ENIAC if your keyboard has numpad. Kana ra may mga numpad na sa kilid, number pad. Alt 164, if you're going to press Alt together with 164 in the numpad, magawa si ENIAC nga gamay. Alt 165 po kung dagko, di ba? If you're familiar with that, then you are familiar with ASCII. Okay, ASCII na siya. Every ASCII character has its corresponding number that when mixed, or I mean when pressed together with Alt, kanang Alt sa inyong keyboard, na siya manggawas ng mga characters. Man siya gitawag ASCII characters. In other words, any number which is symbolically represented to the system in a method is called a number system. And these numbers can efficiently perform mathematical operations like addition, subtraction, multiplication, and division. Every number can be uniquely represented using this technique, and the number system is defined by the numbers or digits in the number system. Again, timan-an din ninyo, binary number consists of 2 digits only, 0 and 1. Decimal consists of 10, 0 up to 9. Octal has 8, 0 up to 7. And finally, the hexadecimal number system consists of 16 digits in our number system, that is 0 up to 9 and A up to F. Alright, so that's all for today's meeting. I hope you have learned something about number systems and how important it is in our daily lives. We are going to meet again for the 4th week, and then right after that one, I'll be giving you 1 whole week for you to study for your CO. Dili pa day, week 6 pa day. So right after week 5, I'm going to give you the 1 whole week in order to study for your course outcome. Thank you so much, and God bless you all.